Hello, my name is Bora. If you're looking to build customer-facing agentic AI applications backed by a database, you've come to the right place. We'll cover a lot, from Bigtable and ADK to Model Armor, so I put together a teaser for you. Cue the hype music. Okay, hopefully that intro got you all excited about the rest of this video. Let's get started with a simple demo of the end product, starting with authentication. User identity is key for our application because all the tools we'll use will need to be scoped down to work with data and services only the end user can access, while agents themselves run as service accounts. In this demo, end user identity is key for not one, but three components: for calendar access, row-level access control in the database, and agent memory. So first, we need to go to Google Auth platform and create our OAuth client. Make sure your origins and redirect URIs are set correctly, and retrieve your client ID and client secret. Next, we'll define our scopes. Please ignore the notifications you see during the login. It is because this is a demo application, so I didn't verify it. Note that I added a scope for Google Calendar access, since our agent will rely on the calendar to book doctor appointments. Let's complete our login flow and meet our friendly agent, and get straight to business. Past appointments, tests, prescriptions, booking new appointments. It would have been quite useful if your healthcare provider had such an agent, wouldn't it? Let's see how it works. Our agent has three sub-agents accessed as tools by our root agent, the so-called agent as tool pattern. The query agent that talks to our database, search agent that grounds answers with context from Google Search and uses maps to find nearby healthcare facilities, the booking agent that looks for available spots in my calendar for doctor appointments, and creates corresponding calendar events. I also have two tools that run before the agent to provide necessary context for personalized responses. Get Profile Info retrieves user age, gender, zip code to support better personalization, while Update Time provides the current date and time to support inquiries and responses that involve relative date time references like last week or past 3 months. Okay, let's ask some more interesting questions before we look at what's happening behind the scenes. This answer demonstrates that our agent was able to associate high blood pressure with the term hypertension and a visit to a cardiologist. It is telling me I was prescribed some new medications, so let's see if I am due for a refill. The agent is able to recognize two medications as heart meds and correctly identifies March 2nd to be in the past and June 11th, 2026 to be in the future. How about my shots? Once again, the agent correctly identifies May 17th as an upcoming date. Note that the appointment itself is a routine checkup, but the description mentions that a flu shot will be administered. The agent doesn't miss this detail. Let's ask one more question that exercises relative time filtering to trigger a response containing multiple data points. We get a nicely formatted table, as our agent instructions involve returning a markdown table for such responses. Now, where does all this data come from? Let's have a look at our underlying tables. In our Bigtable instance, we have a table called Patients with 4 column families: profile, prescriptions, visits, and tests, keyed by user email. Bigtable column families are represented as maps in SQL, which are key value pairs. For example, the tests family consists of keys for each type of test, such as glucose or cholesterol, with test results as values and a timestamp of when the test was done, which appears like a JSON document. If you didn't know Bigtable had a SQL API, that's yet another nugget of information from this demo. Note that all this data is randomly generated, so a lot of the values won't make sense. Let's see what else our agent can do. Look at that stylish interactive chart. Okay, time to look at how all this works. First, the building blocks. Our demo uses Query Tool in Bigtable's ADK toolset that can convert SQL queries into function tools in just a few lines of code. ADK's tool context allows us to backchannel information like user identity without interference from the agent and use it for row-level access control. Finally, Agentic will help us deal with SQL injection. We'll add another layer of protection using Model Armor towards the end of the video. The tool that returned the data for the chart was getTestResults. It takes 3 arguments, start and end dates, and number of results. While types are listed, Python isn't strongly typed, so we'll use Pydantic to do the type enforcement. We build our SQL statement by putting before, after, and number of tests parameters in place. The agent will set number of tests to 1 if user asks for the latest. Finally, we implement row-level security by filtering by our user's identity, provided by tool context. Tool context is not set by the agent. This is very important because we don't want users to claim they are somebody else and trick the agent to access health records they weren't supposed to see.
Function tool approach works well for operational use cases, whether it is to respond to inquiries about a user's recent orders or support tickets. It simplifies the process, as you only need a few tools because there are only so many orders or support tickets a user could have. And with agent context windows growing and the cost of tokens going down, this will only get better. If you need to process a lot of data to distill a small amount of information, however, Google also offers specialized tools. For faceted search, Data Agent Developer Platform might serve you better. For analytics, check out Conversational Analytics API.
Now let's see whether Pydantic will help us catch some SQL injection attempts. Let's run our test. The issue was caught and the query was blocked from execution. You can see here my attempt to bypass row key filter that limits scope to my personal records. Lastly, let's have a look at how the chart was generated. For this demo, I used recharts visualization library, so I simply told the agent to return the results in recharts JSON format. Now, let's ask questions that the agent can't answer by just relying on running a single database query. For this one, the agent not only needs my medical history, it also needs to figure out what is typical for someone of my age. The response is spot on. Let's ask another one. Answering this requires finding my next appointment, the tests that will be administered, and whether those tests require fasting. Yet again, a great answer. The easiest way to understand what's happening under the covers is using ADK Web. Let's ask a question and see the steps taken by the agent. Root agent first calls the medical records agent to retrieve past procedures and their results. Then it combines that information with my age and gender retrieved earlier and passed on to the search agent to find the typical frequency. The root agent combines all the responses from subagents to form the final response. Let's ask one more question that would require a similar level of personalization and multi-step reasoning. The agent gives quite comprehensive answers, taking into account past procedures and test results by comparing against search grounding. We tested the agent with a lot of ad hoc questions, but as you iterate through different versions of the agents and tweak agent instructions, tool descriptions, query definitions, etc., it is much better to write evals to detect regressions and see if the changes are moving the response quality in the right direction. ADK provides a nice visual way to see the issues and step through them. You can see the eval results in my IDE, and once you have evals, it gets a lot easier to iteratively improve quality. In this case, you can see that my coding agent is already recommending improvements. I didn't just take this particular advice. I created a hill climbing loop here where my agent runs the evals, makes tweaks, and runs again, self-tuning without my manual intervention. Of course, this wouldn't be a health concierge if it couldn't book appointments for me, so let's get an appointment set up. For this, I created some fake meetings in my personal calendar so the agent can come back with available slots. I'm using ADK's calendar tool and filtering down to a few tools I need to find availability, create appointments, and cancel or modify existing doctor appointments. Let's do 7 p.m. and check if the agent was actually able to create the invite. And there it is. Before we wrap up, there is one last thing I would like to demonstrate. We talked about SQL injection earlier in the demo, but did not cover prompt injection. I will set up a Model Armor template. There are many controls, but I will just pick injection and jailbreaking for this demo. To use this template, I will rely on callbacks again. Model Armor can check for malicious and sensitive content going in or out, like agent instructions, social security, and credit card numbers. Let's make a jailbreaking attempt to set our agent free of previous instructions. And Model Armor wouldn't let it through. I hope you like this demo. Stay tuned for more examples in Code Labs.